Hi to everyone. MM School of Engineering, Department of Mechanical Engineering, Subject Mechatronics, Unit number 4, Programmable Logic Devices. Okay, online classes. Okay, last class we discussed about what is PLC, what are the application of PLC in the industry. Okay, like that we discussed. Then we discussed about the architecture of PLC. What are the internal block diagrams available in PLC? Then what are the input output modules available in the PLC? Like that we discussed. Then comparison between the processor, microprocessor, and PLC we discussed. So in this class we are going to discuss about ladder diagram and ladder logic. Okay, so that is if you want to program a PLC, we need a program module. Okay, so that is here they are using the programming language of PLC. Okay, in microprocessor they are using mnemonics like that PLCs, that is instruction set they are using. Here they are using a ladder logic for executing for processing the input and output. Okay, that is ladder programming. So ladder diagram, it is a program languages of PLC. So ladder diagram. So official name given in the international PLC program standard is IEC 61131. So symbols represent opening and closing relays, counters, timers, shift register, and etc. That is here we are going to define a symbols for a opening and close of some devices. There is some output devices, relay, timers, shift registers, and etc. So symbols are arranged in the decide program routine. Okay. So rules in ladder logic are termed as rung, and each rung has a single output. Okay. So these are the logic behind the ladder diagram. There are 7 basic parts of ladder diagram. So mainly we have 2. That is rails. So 2 rails, that is called power rails. So in a ladder diagram represented by vertical lines. The power flow from the left hand side to the right hand side. Rungs means horizontal lines, that is connect the rails to the logic expressions. That is connect the rails in the logic expressions. That is in rails we are transferring the power flow. So one place to another place, like that power flow. So between we are connecting the devices using the rungs. Then inputs. Inputs are external control actions. Inputs are external control actions, that is sensors and transducers. Example, push buttons, limited switch being triggered. Inputs are hardwired to the PLC terminals, represented in the ladder diagram by normally open or normally closed contact symbol. Then output. So outputs are external devices, that is actuators. So turn on and off an electrical motor or a solenoid valve. The outputs are hardwired to the PLC terminals, represented in the ladder diagram, so by a relay coil symbol. The logical expressions. The logical expressions are used in combination with the input and output for formulate the decide control operations. So then address notation describe the input output logical expressions, memory addressing structure of PLC. Okay, then tag names for select define the which process we are going to done, that is AND logic or logic, then motor closely opened or normally opened, like that we need to tag the program, that is descriptions allocated to the addresses. Then comments. So it is an important part of the ladder diagram. Comments are displayed at the start of each rung, used to describe the logical expressions and control operations that are rung. So understanding ladder diagrams are easier by using commands. Okay, this is a best example for ladder diagram. So this part is right. So this part is right. There is an input and output between. So we are connecting is the rungs, that is rung 1, rung 2, and rung 3. Okay. So these are the devices that is normally closed. So this is normally closed condition. This is normally opened condition. This is the motor condition. Motor whether on or off. If motor is on, it is glow as a green. If motor is off, means it will glow as a red. So like that we are adding the using these switches. Using these switches, we are going to develop the logic. They like that and or not, like that we are going to add the series and parallel logics. Okay, so this is a ladder diagram symbol for used programming. That is, first one is normally open relay contact. So it is normally opened. When power supply is came, it will be closed. Okay, that means it will connect the input to the output. So second one is normally closed relay contact. That is, already it will be closed condition. That means already power flow will be there, input and output module. So but when we are giving the power supply, means it will be negative. That is, it will convert into the normally open conditions. Okay, like that we are using the contacts, then relay coil, then indicating lamp for executing, then heating element, solenoid coils, normally open push switch, normally closed push button switch, then electrical motor in this three phase concept, then fuse, then overload heater. Like that we are using the this kind of symbols we are using in the ladder diagram functions. So out the read logic they are used in the ladder. So binary principle is that the events can be thrown in one of two states. The states can be defined as 1 or 0, true or false, on or off, high or low, or yes or no. So ladder logic uses simple expressions on the graphical editor for reading and writing code, making it easier. If real world event is transferred into large ladder logic, it is symbolically expressed in the form of normally open contact. Example, even like a button being pushed or a limit switch is being activated. So for example, consider the event A as one of two states, true or false. Okay, 1 or 0. So event is associated with the normal open contact can be true or false. If the event is true, highlighted in the green. So already I told, that is, if event is true, means it will be green. Okay, this is the concept. So then normally open contact alone cannot decide what action to take the automate the event. It merely tells what is the state of the event. So logic is the ability to decide what action needs to be taken depending on the state of one or more events. So logic concept, if comma then logic functions. So ladder logic functions, consider an event A allocated to normally closed contact. In a ladder logic, the events are defined as PLC input. So let the result of the logical function is equal to Y. The result of the rung logic function is defined as the PLC output. The two fundamental elements on a rung in a ladder diagram is first line of code. So this is a simple example of a ladder logic basic inbuilt function, that is have if and then operation. Okay, that is, if A is equal to false, then Y is equal to false. If A is equal to 0, then Y is equal to true, because there is no condition between these two. Okay, if A is green, output will be green. If A is red, output will be red. Like that they are using in the ladder logic functions. This is the same concept. So other fundamental logics are not and are. Okay, here they are using if and then. That means both, if both the inputs are 1, that is both the inputs are true, then only output will be enabled. Okay, this is the concept of AND gate. We know that AND gate logic. So the truth table they are defined in these ladder functions. It is OR logic. If any one of the input is true, so output will be true. This is a concept. Okay, the basic logic concept, our logic concept used in this function. So sequence followed by the PLC when carrying out a program. So scan the inputs associated with the one rung of ladder program. So solve the logic operation involving those inputs. Set or reset the output for the rung. So move on the next rung and repeat operation 1, 2, 3. Then move on the next rung and repeat the operation 1, 2, 3. Okay. So each rung it is separately executed from the series concept one by one. Okay. So until the end of the program, which each rank of the ladder program, okay, then it will go to the first one. The PLC that goes back to the beginning of the program and start again for continuous process. Because if you want to rotate a motor for a continuous concept, we need to repeatedly execute the program. This is another example of ladder logic. They are using the end program for the process. So these are the input and output processing and programming of PLC. Okay. So I hope that you all know about the basics of ladder logic functions and ladder logic symbols and what is the advantage of ladder used in the PLC, like that we discussed in the class. Okay. Thank you.